Hello everyone. Today I would like to introduce to you an application named AI Predictor, developed by the team at Outscada Lab. This application is designed to analyze historical data and provide future data predictions. Its purpose is to give users a more comprehensive overview of past and future data in order to come up with timely action plans and avoid losses for businesses or companies. So, this application has been integrated into the installation package, Outscada version 5.0.0.1, which is attached on at scada.com. Once you have installed the installation package, Resource Installation Manager, in sections 21 and 22, you will see two applications named AI Predictor and Documentation. The documentation file is a part. That is the user manual in PDF file format. Now I will proceed to install this AI Predictor application. Alright, after finishing the installation, we will go to the path. C Drive Program Files, the App Pro folder. The main folder is AI Predictor. Here we will see the file aipredictor.exe. Now I will proceed to open the application. During the initial startup time when opening the application, it will take about 10 to 20 seconds. The reason is that the application will download necessary libraries to be able to perform predictions as well as data analysis. Alright, after I have launched the application, we will see the interface. So, the application interface includes a menu on the left. There will be tabs such as Data Source, Parameter, Result, Charts and Setting. The purpose of each tab is it represents each step that we will take when using this application. The first tab is the Data Source tab. Its purpose is for us to import or select the historical data CSV file that we want this system to analyze and make predictions on. Regarding the file structure, I also have it must follow a specific format. I will provide an example in the description below. So, the CSV file of historical data needs to satisfy two conditions. First, it must have the first column as the date-time column because historical data follows the rule of being logged over time. Day, month, hour, minute, so there must be a column named date-time. And the second column is the data column that the system needs to analyze. For the date-time column, we can use any format, for example month, day, or year, month, day. The system can analyze and recognize them all. For the Y data column, it can have decimal parts. Now I will proceed to open a CSV file for demonstration. And this is a CSV file that I have prepared. This CSV file is for power consumption, which is the electricity consumption level of a factory. This factory has three areas, Zone 1, Zone 2, the first column is the date-time column, which is currently in month, day, and year format, and includes the logging time. My power consumption file has a time period from January 1st, 2017 to December 30th, 2017, which is exactly 1 full year. So, this full year with a logging frequency of 10 minutes. The system logs data once, with data for Zone 1, Zone 2, and Zone 3. Now I will proceed to have the system analyze this data file and start making future predictions. For the first step, I will select that data file. After selecting the data file, we will move to the second tab, the Parameters tab. In this Parameters tab, there is a configuration section for us to choose the number of future prediction steps that we want the system to predict. By default, when opened, it will be 30 steps. meaning from the last date in the historical data file. Adding the number of steps that we configure here. For example, here I am configuring 30 steps. The last date in my old data file is December 30th. So the first date of the next step would be December 31st. And counting up to 30 steps. For example, here it is December 30th, 2017, configuring 30 steps for future data prediction. It would fall around January 30th, 2018. Alright, after we have selected the file and configured the future steps that we want the system to analyze, we will click on the Run Prediction button. Now the system will proceed to read and analyze our CSV file, mapping the data columns automatically, and proceed to analyze the data in column 1, which is the column for zone 1. Column 2 is for zone 2, and proceed to analyze column 3 for zone 3. The time the system takes to perform the analysis will be about 10 to 30 seconds, depending on the size of the historical data file. Since my file is quite large, the analysis time takes about 20 seconds. After the system has finished analyzing and successfully made predictions, it will notify Predict Completed. It will automatically switch us from earlier when we were on tab number to parameter. The system will automatically switch to the Results tab. Here we can view the parameters that the system obtained. After analyzing the data and making predictions, to provide these parameters, I will explain these parameters, for example the M parameter. MAE, MAP, accuracy. These are analyses regarding correct predictions, AI terminology. In this Results tab, we will see first, the data columns that are in our historical data file. After being analyzed by the system, will be selected by the LSTM model. The best model column is the column that represents the model evaluated for this data column. In this system, Otscada Lab has integrated 3 main prediction models that are commonly and widely used today, such as PHÁP, LSTM, and Transformer. After the system analyzes, it will select the model that the system deems most accurate for analysis and provides MAP, accuracy metrics, with absolute accuracy and the highest scores. As you can see here, all 3 columns were selected for analysis by the LSTM model and have provided scores that are suitable and the best among all 3 models. Let me explain about the MAE score. It is the mean absolute error. When the model analyzes and predicts, it will filter the scores and provide the MAE score. The lower this MAE score, the higher the reliability and accuracy of this model. Similarly for MAP, it is like MAE but converted to a percentage. With a score that is less than 10, it represents. The lower this MAP, the higher the confidence and the better this model is, and certainly, the smaller it is than 10, the higher the accuracy becomes. Here for Zone 1, its score is only 3.82%, meaning its accuracy is up to 97%, actually 96.18%. And this accuracy is the percentage of accuracy compared to when the model was tested on the historical data set, including both test set and validation set. The final result is future step, which is the part we configured in the parameter tab after obtaining the scores, as well as having selected the model. The best model we will move to the Charts tab to view an overview of the predictions from this model. In the Charts tab, there will be sections, like the column selector for us to choose the data column we want to view. As here, in the file I introduced earlier, it has 3 columns: Zone 1, Zone 2, and Zone 3. Now I will analyze Zone 1 first. In this Charts tab, the Model and Data Charts, historical data has been plotted into this chart. The gray line is the training set. The training set is the historical data from the file that has been plotted here. Next is the validation data. The validation data is the data that the model uses when plotting. It is not included in the training set, but uses this validation data for the model to evaluate its accuracy level. And finally, the red line is the test line. After the model has evaluated the validation line, it has selected the model that it considers most suitable and accurate. Here, as it has selected the LSTM model, it will begin plotting the test line. This test data is also actual data from the CSV file, but the model was not exposed to or aware of it during the model selection process. Once the validation data has been plotted, and the model has been selected, which is LSTM, this model will plot a model data line over the validation dataset. We can mark this as validation. But from the LSTM model, while the yellow line is the validation, but it's the actual data from the CSV file. Similarly for the test set, it will also plot over the test line to be able to evaluate the accuracy level of the model, and the yellow dash line is the future data that the model. After having analyzed and selected the best model, we'll also rely on that model to provide future prediction data. Looking at this model, we can see that the validation and test lines and predictions. The model closely follows the historical data. In this Charts tab, there are also tuning components that allow us to observe data accurately and most intuitively by being able to move, drag left, drag right, or use the zoom magnifying glass at the bottom here to see what the actual data looks like. After I have zoomed in, we can see the data lines, as well as the future prediction lines. If I want to return to the original view, I'll click Reset. And the left and right buttons are for the view we just saw. Similarly for Zone 2 and Zone 3, we can see the model, the historical data as well as test data, validation data, and data plotted by the LSTM model. Looking here, we can assess the accuracy level of this system, and we can determine the confidence level to make early decisions in the future. After we have successfully viewed the chart data, we can export the report to an Excel file to be able to see the exact data that the model predicts. When viewing the data on these charts, we cannot see exactly what the predicted data values will be. So, we will use the Export Results function to view this data. And here, after I have successfully exported, it will open an Excel file automatically containing the data. For example, data that can be viewed directly from the table. And secondly, the data for each column in the CSV file. When exported, the exported data will also include historical data. This is the historical data that was input into the model for learning and prediction. This is the last 30 days of historical data. And the second column is the prediction column, which is the column the model predicts for the next 30 days, depending on the future step we configured in the parameter step. This is the actual prediction data from the model. Similarly for Zone 2 and Zone 3. Along with that, there will also be a chart to clearly illustrate the data provided by the model. So that was a file about the electricity consumption level of a factory. Now I will proceed to try predicting another file, which is the historical data of Bitcoin from August 2025 to the present, which is February 2026. Now I will select. This is the historical data of Bitcoin with the unit in USD. Now I will proceed to select this Bitcoin data file. Then I will configure 30 days. Predict for the next 30 days. Proceed to run prediction. After about 10 to 15 seconds, the system has finished analyzing the historical data and provided prediction data for the next 30 days. For Bitcoin, similar to the sample file earlier. After the prediction is complete, it will automatically switch to the Results tab with information such as the column. The target column is the column I put in the historical data file earlier, named BTC, and the system has selected the best model, which is the transformer model for Bitcoin prediction, with scores made for 0.48%. Quite low, so we can trust and assess that the reliability of this model is high. Accuracy is 91.94% out of 100%. After having the data, I will proceed to switch to the Charts tab to view the actual data. As we can see here, the training set is the data from early April to October. The model will divide into training set for the model to learn from this Bitcoin data. After successfully training, the model proceeds to produce the validation set. The validation set and test set are the two datasets that the model did not learn from, were not included in the training set to ensure the most accurate predictions. After having validation and test, the model will plot the validation using the transformer model. As we can see here, the model's validation part, transformer and actual data validation, they are quite close to each other. Actually, the error margin is quite small. This is the test part. Transformer test compared to actual test data. And finally, the data and predictions provided. Predictions from the transformer model. We can export the results to see the actual data. And this is the actual data that the model learned from the input data. This is the actual data from the last 30 days, from January 14, 2026 to February 2nd. And starting predictions from February 3rd to March 4th, 2026. The Bitcoin data will have figures like this. My presentation ends here. Thank you all for listening and watching.